What is the observable universe? The observable universe refers to the portion of the entire universe that we can see and study using telescopes and other scientific instruments. Our ability to observe the cosmos is limited by the finite speed of light, our main source of information. Because light takes time to travel, we can only observe objects whose light has had time to reach us since the beginning of the universe. Even though the universe is estimated to be 13.8 billion years old, the diameter of the observable universe is about 93 billion light years. This apparent contradiction is due to the universe's continuous expansion. As space stretches, objects that emitted light long ago are now much farther away than when that light was first emitted. Despite its vastness, the observable universe is just a small part of the entire cosmos, and there's still much we don't know. However, through powerful instruments like NASA's James Webb Space Telescope, JWST, we continue to uncover valuable insights about the universe's structure, composition, and history. Discoveries in the observable universe. One of the most significant tools in modern astronomy, the James Webb Space Telescope, has enabled us to peer deeper into space than ever before. It has recently captured images of distant galaxies that formed only a few 100 million years after the Big Bang. These discoveries help scientists better understand how stars and galaxies formed in the early universe. The JWST detects infrared light, which is especially useful for observing ancient galaxies whose light has been stretched to longer wavelengths due to cosmic expansion. Thanks to this capability, researchers have found a surprisingly high number of galaxies that were forming stars in the early universe. This deepens our understanding of how the cosmos evolved in its infancy. What lies beyond the observable universe? The observable universe is not the limit of everything that exists. The theory of cosmic inflation suggests that the universe is at least 10 superscript 2 superscript 3 times larger than what we can observe, an unimaginably vast expanse. Because light from regions beyond the observable universe hasn't had time to reach us, we cannot directly study those areas. Still, scientists use observations from within the observable universe to develop models and theories about what might lie beyond. Some speculative ideas suggest that advanced technologies, such as warp drives or wormholes, might one day allow us to explore beyond our current limits. However, such concepts remain theoretical, and many scientists believe that faster-than-light travel is physically impossible based on our current understanding of the universe. Are we alone in the universe? The vastness of the universe naturally raises the question, are we alone? With billions of galaxies and countless stars, it's hard to believe that Earth is the only place where life exists. Thanks to telescopes like JWST and other observational methods, scientists have discovered thousands of exoplanets, planets outside our solar system. Some of these planets show conditions that could potentially support life. For example, WASP 96b, an exoplanet studied using the James Webb Telescope, revealed water molecules in its atmosphere, along with signs of haze and clouds. This finding challenges previous assumptions about what a habitable planet might look like. As technology and research advance, the possibility of discovering life elsewhere in the universe becomes increasingly plausible. Every new discovery not only broadens our knowledge, but also fuels our sense of wonder, curiosity, and awe at the incredible scale and mystery of the cosmos. While we have yet to find conclusive proof, ongoing discoveries and evidence suggest that extraterrestrial life is a fascinating and plausible possibility. But what about the multiverse in the context of our vast observable universe? The possibilities are truly endless. The concept of the multiverse, also known as the many worlds interpretation, is a theoretical idea from physics and philosophy. It proposes the existence of multiple parallel universes or dimensions beyond our own. This idea is most commonly discussed in quantum physics, which explores the behavior of particles at the atomic and subatomic levels. According to some interpretations of quantum physics, observation causes a quantum system to collapse into a single state. However, in the many worlds interpretation, each possible outcome actually occurs, leading to the creation of multiple parallel realities. It's important to recognize that the multiverse theory remains highly speculative and lacks conclusive evidence. As such, it's difficult to determine with certainty whether the concept is scientifically valid. While some scientists and philosophers find the multiverse intriguing and potentially helpful in explaining certain phenomena. Others remain skeptical. Given our limited knowledge of what exists beyond the boundaries of our universe, the idea of a multiverse remains as conceivable as Schrödinger's cat paradox or the true nature of darkness. It's a concept that invites curiosity and contemplation, but demands more research and empirical support to be confirmed. Now, what about the phenomenon known as dark flow? First proposed in 2008, dark flow raises another complex and thought-provoking question. The observation that some galaxy clusters seem to be moving faster than expected, based on the distribution of matter in the universe, has led to the concept of dark flow. This theory suggests that galaxy clusters may be influenced by an unknown form of dark matter or dark energy, which should be pulling them in a particular direction. However, the idea of dark flow remains controversial and has not been widely accepted by the scientific community. While some studies support the existence of dark flow, arguing that it could be caused by a massive structure in the universe exerting a gravitational pull on galaxy clusters, other research fails to confirm this hypothesis. Critics propose that the observed movement could be due to systematic errors in measurements. Additionally, some scientists speculate that the motion of these clusters might be linked to factors outside the observable universe. As such, further research and evidence are needed before any conclusions can be made about this mysterious phenomenon. Dark matter and dark energy, accounting for approximately 95% of the universe, remain two of the greatest unsolved mysteries in cosmology. Despite their enormous impact on the universe's structure and evolution, we have not yet been able to directly detect either of these elusive components. As research continues, new discoveries will undoubtedly open up more opportunities for exploration, whether it's studying dark matter, looking for signs of alien life, or delving into the very fabric of space-time. The pursuit of understanding the cosmos will continue to drive scientific inquiry for generations to come.